Okay, so this is the review for test number 2. So the first 3 questions, it says to factor completely. So the first one is 15s minus 60s to the third power. So we have 15s. I'll try to make sure my s's don't look like 5s. So hold on here. 15s minus 60s to the third power. So remember, the first thing we always look for is GCF, and there is a GCF, and the GCF is 15s. So then I get 1 minus 4s squared. So now I look inside the parentheses, and I notice inside the parentheses I can factor that again. That is the difference of 2 perfect squares. It's dots. So I bring down the GCF, 15s, 2 parentheses for dots. One is a plus, one's a minus. To figure out what goes inside, you do the square root of these. The square root of 1 is 1. The square root of 4 is 2. And the square root of s squared is s. So my answer is 15s times 1 plus 2s times 1 minus 2s. All right, so let's take a look at number 2. So I noticed with number 2 that it is 4 terms. Now remember, just because it's 4 terms doesn't automatically mean right away that it'll be grouping. Remember, always look for a GCF first. So we have 5x to the 4th minus 35x to the 3rd minus 45x squared plus 315x. So I notice there is a GCF, and that GCF is 5x. So I'm going to factor out the 5x, and then I'm left with x to the 3rd minus 7x squared minus 9x plus 63. Okay, so now that I factored out the GCF, now I'm going to do grouping. So I'm going to have the red group here, and I'm going to have the green group here. All right, so in the red group here, there's a GCF, and that GCF is x squared times x minus 7. In the green group, my GCF is negative 9, right? There's that negative, so I bring that down. And then I get x minus 7. So my factors so far are x squared minus 9 and x minus 7. And don't forget, we still have this guy here, 5x. All right, look inside the parentheses. So I notice right here, that's the difference of 2 perfect squares. So that's x plus 3 and x minus 3. Bring down the GCF and bring down the x minus 7. Now it's factored completely. All right, let's take a look at number 3. So we have number 3 is x to the 9th, y to the 9th. So I notice that it's only 2 terms. It is not the difference of 2 perfect squares because x to the 9th and y to the 9th are not perfect squares. Remember, they have to have even exponents. So is it perfect cubes? Yes, it's perfect cubes. Y to the 9th and x to the 9th are both perfect cubes. All right, so remember our SOAP, right? Same, opposite, always positive. So I'm going to have, just going to fill in the formula right now. Same sign, opposite sign, always positive. Remember, the front and the end of the first little parentheses is a and b to the first power. Second parentheses is a squared to start off. Sorry, I messed that up. All right, so we have a squared and b squared at the end. And in the middle is a times b. All right, so now we need to get our a and our b. So we want a is the cube root of the first term, x to the 9th. So the cube root of x to the 9th is x to the 3rd. Remember, you take the exponent, 9, and divide by the index, which is 3. B is the cube root of y to the 9th, which would be y to the third. So I'm just going to fill in. All right, so I have x to the third is my a minus my b, which is y to the third, times. So we have to square the a. So we have x to the third squared plus a times b, so that's x to the third times y to the third, plus b squared, so it's y to the third squared. So I'm just going to clean this up. X to the third minus y to the third times. Remember, when we have a power to a power, multiply the power, so that's x to the 6 plus x to the third y to the third plus y to the 6th power. Now I notice here, this is perfect cubes again, so you have to factor that again. So it's going to be the same formula since it's minus. Same sign, opposite sign, always positive. So we have a is the cube root of x to the third, which is x, and b is the cube root of y to the third, which is y. So it's going to be x minus y, x squared, because you square the a times b, which is xy, and the last term, which is y squared. Now you have to remember, we do have this that we didn't do anything with. This, what I just did in green, is this factored. So now I just have to write the whole thing. X minus y, x squared plus xy plus y squared, and then I have this guy here. So it's x to the 6 plus x cubed y cubed plus y to the 6th power. Okay, so let's take a look at number 4. So number 4 is the nature of the root. So remember, where nature of the roots means what kind of roots do I have? Do I have real, rational, equal? These are your choices. They could be real. The only time they're not real is when it's imaginary. Real, rational, equal, real, rational, unequal, real, irrational, unequal, imaginary. Okay, those are your 4 choices. All right, so remember, we want to do the discriminant. The discriminant is what's under the square root symbol from the quadratic formula, which is b squared minus 4ac. All right, so let's take a look at 4. A is 1, b is negative 3, and c is negative 2. So we're going to plug it in. So I have negative 3 squared. Notice I use parentheses. Minus 4 times 1 times negative 2. Just plug that in the calculator all at one time. Right? We're not going to do piece by piece. And we get 17. So now you want to think about it. All right, you have the square root of 17. Are they real? Yes. The only time they're not real is if it's imaginary. And you should remember, when we get imaginary, you have to have that negative under the square root. The square root of 17, is that rational or irrational? Can you take the square root of 17? No. So therefore, it's irrational. And it's going to be unequal. Right? Irrational is always going to be unequal. Okay. So let's take a look at number 5. Okay, so number 5, we're going to identify what the A, B, and the C are. So number 5A. Oh, actually I can't, because notice this is not in the right form. So I have to put it in the right form first. So let me rewrite it. So when I rewrite this, we're going to get 5x squared minus 2x equals negative 1. I have to get it to equal 0, so I have to add the 1 over. So it's 5x squared minus 2x plus 1 equals 0. All right, the A is 5, B is negative 2, C is equal to 1. So we're going to plug it into the formula. Negative 2 squared minus 4 times 5 times 1. So plug that in the calculator all at one time. The discriminant is negative 16. So think about that. When I have the square root of negative 16, remember, it's coming from the quadratic formula. This is imaginary. When you get a negative under the square root, it's imaginary. Imaginary roots. Okay, so let's take a look at the next one, which is number 6. Okay, so number 6 is x squared plus 9 equals 6x. So again, that's not in the right form, so we have to minus 6x over. All right, so we're going to identify A, which is 1, B, which is negative 6, and C, which is equal to 9. Okay, so now we are going to find the discriminant, which is B squared minus 4AC. So it's negative 6 squared minus 4 times 1 times 9. Plug that in the calculator and you get 0. So think about this. You have the square root of 0. Are they real? Yes. Rational? Yes, because you could take the square root of 0. The square root of 0 is 0, so that's rational. And they are going to be equal because you're adding. So think about the quadratic formula. It's plus minus in here, right? You have a number plus 0 and a number minus 0. You're going to get the same exact number. So they're real, rational, and equal. Okay, next one. We have, so number 7. Okay, so number 7 is x squared minus 4x plus 4 equals 25. So we have to minus the 25 over. X squared minus 4x minus 21 equals 0. A is 1. B is negative 4. C is negative 21. So we have negative 4 squared minus 4 times 1 times negative 21. Plug that in the calculator all at one time, we get 10. So think about the quadratic formula. We have the square root of 10. That is real. That is now imaginary. Oh, sorry, irrational, because you can't take the square root of 10. And that is unequal. Okay, so the next one, number 8, it says, given 2x squared plus 4x plus m equals 0, determine the value or values of m that will make the roots of the quadratic equation, and we have 8 and 9. We're looking for the roots to be real, rational, and equal. Now remember, in order for the roots to be real, rational, equal, the discriminant, b squared minus 4ac, in order for them to be equal, I have to get a 0 under the radical. Right, so now I'm just going to plug in my numbers. So I have b is 4, so it's 4 squared, minus 4 times a, which is 2. C is your m. That's my constant. That has to equal 0. So we're just going to solve this. 16 minus 8m equals 0. Minus 16, so I get negative 8m equals negative 16. Divide by negative 8, and we get positive 2. So when m is positive 2, my roots will be equal. All right, the next one, I want my roots to be imaginary. Now remember, in order to get imaginary roots, your discriminant, b squared minus 4ac, has to be less than 0, has to be a negative number, so that means less than 0. So plug in the numbers, 4 squared minus 4 times 2 times m, and that has to be less than 0. So 16 minus 8m has to be less than 0. Minus 16 over negative 8m is less than negative 16. Divide by negative 8. Now remember, be careful, when you divide, when you have an inequality, this is an inequality because it's the greater than symbol. when you have an inequality and you divide by a negative number, I'm dividing by -8, it flips the sign. So I have m is greater than 2. So any number greater than 2 will make my roots imaginary. Okay, so let's take a look at the next one. Okay, so I have the same thing for 10 and 11. Given the equation 3x squared minus 6x plus m equals 0, find the value of m that will make the roots of the quadratic equation. I want them real, rational, equal. Now remember, real, rational, equal, your discriminant, b squared minus 4ac, has to be equal to 0. So let's plug in the numbers. -6 squared minus 4 times 3 times m equals 0. 36 minus 12m equals 0. Solve for m. Minus 36 from both sides. -12m equals -36. Divide by -12, we get m is equal to 3. When m is equal to 3, I will have real, rational, equal roots. All right, so let's take a look at the next one. I want my roots to be imaginary. So remember, b squared minus 4ac, the discriminant has to be a negative number, any negative number. So as long as it's less than 0, right, because less than 0 means it's negative, I will get imaginary. My discriminant, as long as it's less than 0, I will get imaginary. So I have -6 squared minus 4 times 3 times m is less than 0. So we have 36 minus 12m is less than 0. Minus 36. Remember, we're dividing by -12, so we flip the sign. So when m is greater than 3, your roots will be imaginary. Okay, now 12 says, explain how you would distinguish if the roots are real, rational, unequal, or if they are real, irrational, and unequal. All right, so for real, now remember, real means it has to be positive. Rational means it has to be a perfect square, and unequal. Okay? So it has, so for real, rational, unequal. So we know it can't be negative. So we know the discriminant must be greater than 0. It can't be equal to 0, because if it's equal to 0, remember that's equal. They're equal roots. Has to be greater than 0 means it's positive, and in order for it to be rational, it has to be a perfect square. So, and a perfect, that's an E, square. All right, now, in order for them to be real, irrational, unequal, your discriminant must be, okay, they have to be greater than 0. Because if it's not greater than 0, then it's less than 0 and it's negative. It can't be equal to 0 either, because then it's equal. And it's not a perfect square. I'll just put square symbol there, okay? All right, so let's take a look at number 13. Okay, so number 13 says determine the roots. So we're solving the quadratics in simplest radical or a plus bi form. So we have to just make sure that we go with the answer as far as we can with the radicals or any negatives that are there. All right, so let's take a look at number 1. I have 3x squared plus 2x minus 3 equals 0. So the first thing I want to check to see if it's factorable. When I multiply first times the last master product, I get negative 9. There are no numbers that multiply to 9 minus to 2. So I have to now decide, do I use quadratic formula or complete the square? Now, in order to complete the square, we'd have to divide by 3. Now, this is going to be a disaster in the middle because it's going to give me fractions. So I want to use quadratic formula. Quadratic formula is x equals negative b plus minus square root of b squared minus 4ac over 2a. Okay, so let's see. It's in the right form, so that means a is 3, b is 2, c is negative 3. All right, let's plug it in. So we have x equals negative whatever b is positive 2, so it's going to be negative 2, plus minus 2 squared minus 4 times 3 times negative 3 over 2 times 3. So I have negative 2 plus minus, plug in what's under the square root, only under the square root, and when you plug in what's under the square root, we get 40. So now we want to simplify the square root of 40. That is 4 and 10, which is 2 the square root of 10. So then I have x equals negative 2 plus minus 2 the square root of 10 over 6. Now we want to make the heart. Everything reduces by 2. This becomes negative 1. Watch the sign. 1 and 3. So x equals negative 1 plus minus the square root of 10. I don't need that 1 in front over 3. All right, let's take a look at number 14. All right, so number 14, which is x plus 1 squared plus 64 equals 0. Now, when I see that, I realize that this here is kind of like the start of complete the square. This number just happens to be on the wrong side. So let's move that number over. So when I move that constant over, now I have x plus 1 squared equals negative 64. So I can solve it right from here. To get rid of the square, you square root both sides. Remember, a square and a square root cancel each other out, so now I'm left with x plus 1 equals. The negative under the square root becomes an I. The square root of 64 is 8. Now remember, we're square rooting, so it's plus minus. Minus 1 from both sides, that goes in front of the plus minus, so it's x equals negative 1 plus minus 8i. That's simplest a plus bi form, which is what it says here. I just happen to have two answers. Okay, so next we'll do is number 15. So when I look at number 15, I notice that I have these parentheses here. So I need to get rid of them. It has to be equal to 0. So let's do that. I have x squared minus 3 equals 3x plus 9. So I want it to be equal to 0, so I'm going to move everything over to the left. X squared minus 3x plus minus 9 equals 0. All right, so now this is not factorable. If it was, I would factor it, but it's not. So I'm going to use the quadratic formula. X equals negative b plus minus the square root of b squared minus 4ac over 2a. A is 1, b is negative 3, c is negative 9. So I want negative whatever b is negative 3 here, so that's going to make that positive 3. So we have negative 3 squared minus 4 times a, which is 1, times c, which is negative 9, over 2 times 1. Again, plug in what's under the square root. So we have 3 plus minus. When I plug in what's under the square root, I get 48 over 2. All right, so now we need to simplify. So we have square root of 16, square root of 3, which is 4 the square root of 3. So I have x equals 3 plus minus 4 the square root of 3 all over 2. I cannot make the heart. Nothing simplifies, so that's my final answer. All right, let's take a look at number 16. So I have x squared minus 14x plus 37 equals 0. So this would be a nice one to complete the square. My leading coefficient is a 1 here. My middle term is even. I just have to move the 37 over. So x squared minus 14x equals negative 37. So now remember, we do half of negative 14, which is negative 7. Squared is 49. We add that to both sides of the equation. X squared minus 14x plus 49 equals negative 37 plus 49. Add that together, and we get 12. I'm going to factor the left side. Remember, the factors are the same. It's x and x. Remember, what goes inside is always the number we squared, which is minus 7. Another way to write x minus 7 times x minus 7 is x minus 7 squared equals 12. To get rid of the square root both sides. X minus 7 equals, don't forget that plus minus the square root of 12. And the square root of 12 can be simplified. Square root of 4, square root of 3, so that's 2 the square root of 3. So it's plus minus 2 the square root of 3. And now add the 7 over. And it's going to go right in front of the plus minus. X equals 7 plus minus 2 the square root of 3. Okay, let's take a look at number 17, please. Okay, so for number 17, I'm going to have to distribute here because I have to get this in the standard form here. All right, so I have x minus 6 squared. I'm sorry, x minus 6 times x plus 5. Equals 12. Now I'm going to go into double distribute. So x times x is x squared. X times 5 is 5x. Negative 6 times x is negative 6x. And negative 6 times 5 is negative 30 equals 12. So I have x squared minus x minus 30 equals 12. And now I have to minus the 12 over because it has to equal 0. So I get negative 42. So this is factorable. So I'm going to do master product here. So I multiply the first times the last. I get negative 42x squared. So what multiplies to 42 minuses to a 1, because there's a 1 there. That would be 7x and 6x. They're going to be different signs, but when I add them, I have to get a negative 1, so it has to be negative 7 plus 6. All right, now I'm going to factor by grouping. Group. GCF of the first group is x times x minus 7. The GCF of the second group is positive 6 times x minus 7. So my two factors are x plus 6 and x minus 7 equals 0. Now remember, to finish solving, you have to make the t-chart, set them equal to 0, solve. X equals negative 6 and x equals positive 7. Okay, so let's take a look at number 18. So number 18 says to simplify, so I have powers of I. So you're going to do I part. I to the 32 power. I to the 32 power is 1 plus. And then we have 3i squared, that's negative 3. Remember, I squared is negative 1. Negative 4i to the 52. So it's minus. Now 4i to the 52 is 4. I to the 5th is I. And I to the 11th is negative I. So I have minus and negative. The minus is from here, and then I to the 11th is negative I. So now I'm going to clean this up. So 1 minus 3 is negative 2. Minus 4 is negative 6. This becomes plus plus, so that's plus 2i. So it's negative 6 plus 2i. All right, number 19. So I have the square root of negative 50 minus the square root of negative 128. So remember, in order to add radicals, you have to have the same radicand. They have to be like terms. The number underneath the radical has to be the same. So I'm going to simplify. So I have I, the square root of 50, that's that negative, under the radical. 25 times 2 is 50. 25 is the perfect square. So this becomes 5i, the square root of 2, minus. So now I have I, the square root of 128. So that's 64 and 2, which makes sense, right? In order for me to add, I have to have the same radicand, so I need to have a 2. The square root of 64 is 8, so I have 8i, the square root of 2. Now that I have the same radicands, they're both 2 underneath the radical. I have the square root of 2. Just add or subtract the coefficients. So 5i minus 8i is negative 3i, the square root of 2. All right, so let's take a look at number 20, which is the inverse. Remember, this symbol here is inverse. So I'm starting off with y equals x to the 4th plus 3 over 2. Sorry, I kind of wrote that funny. X to the 4th plus 3 over 2. All right, so I switch x and y. X equals y to the 4th plus 3 over 2. So I'm going to put x over 1 and cross multiply. 2x equals y to the 4th plus 3 minus the 3 over 2x minus 3 equals y to the 4th. Now, to get rid of a 4th power, you have to 4th root it. So I have a 4th power, so I need to 4th root it. So the 4th root of both sides, that takes care of that. So I get y equals the 4th root of 2x minus 3. Now I write it as an inverse. So the inverse of f of x is equal to the 4th root of 2x minus 3. Okay, and let's take a look at 21, which has multiple parts here. All right, so let's see what it says. It says the width of a rectangle is represented by x minus 6, and the length is represented by x plus 7. So I'm going to start off by just drawing a picture here. So here's my rectangle. The length is x plus 7, and the width is x minus 6. A says, find the perimeter as a polynomial. Okay, which means you're not going to have a number answer. You're not going to find that perimeter. It's going to be like 5. You should have x's in your answer. All right, so perimeter, remember, is add all sides. So now remember, it is a rectangle, so all sides are the same. Sorry, not all sides are the same. Opposite sides are the same. So P equals, we have an x plus 7 plus x minus 6. The top is going to be x plus 7. And the side on the left will be x minus 6. Combine like terms, we get 4x. And then we have 7 plus 7 is 14. Negative 6 and negative 6 is negative 12. So we have negative 12 plus 14 is positive 2. That's the perimeter. That's A. B says, if the perimeter is 66, so now it's saying your perimeter is 66, find the dimensions. So in order to find the dimensions, you have to figure out what x is. You have to have this so that you can plug it in. All right, so I know my perimeter is, I know my perimeter is 4x plus 2, so that has to be equal to 66. All right, so let's solve it. 4x equals 64. Divide both sides by 4. x is equal to 16. So now I can find the length and the width, right? So your width is equal to 16 minus 6, which is 10, and the length is equal to 16 plus 7, which is equal to 23. All right, so now let's take a look at C. I'm going to get rid of the A and B so I can have my picture here. Actually, no, I'm going to have to redraw the picture here. All right, so let me just redraw this picture. X plus 7, x minus 6. Okay, so the next part says C, if the length is decreased by 1. So I'm going to take my length and decrease it by 1. So I'm minusing 1. So I'm just going to rewrite this. This is x plus 6 now, right, when I combine like terms. And I increase the width by 2. So I'm adding 2 to the width. So now this is x minus 4. All right, so now this is what I'm using. It says represent the area of the rectangle as a polynomial. So remember, the area of a rectangle, remember this is C, area is length times width. So area equals length, x plus 6, times width, which is x minus 4. So we're going to double distribute because this is not a polynomial. So A equals x times x is x squared. X times negative 4 is negative 4x. 6 times x is 6x, and 6 times negative 4 is negative 24. So the area is equal to, when I clean this up, x squared plus 2x minus 24. All right, now part D. That was C. D says, find the dimensions. That means you have to find x, so you can plug the x in. If the area is 39, so your area is equal to 39. So that means your x squared plus 2x minus 24 has to equal 39. All right, so now I'm going to solve this quadratic. So I'm going to minus 39 from both sides. Negative 24 minus 39 is 63, negative 63 equals 0. So now I got to solve this. So you can solve this any way you want. This does look like a good problem to complete the square because my leading coefficient is a 1. My middle term is even. So I'm going to add the 63 over so that I have x squared plus 2x equals 63. This is also factorable. A problem like this would be factorable because it wouldn't make sense to have an irrational length. Okay, but you can use the quadratic formula. But I'm just going to complete the square because for me, that's quicker. So I'm going to do half of 2, which is 1. Square it, which is 1. Add that to both sides. 63 plus 1 is 64. And now I'm going to factor. So I have x and x. Remember, the number that goes inside there is the number that we square, which is positive 1, positive 1. So that's x plus 1 squared equals 64. To get rid of the square, we're going to square root both sides. I'm sure you remember that. So we get x plus 1 equals, the square root of 64 is 8, but I'm square rooting, so it's plus minus. Minus the 1 over. X equals negative 1 plus minus 8. You do have to finish this. Negative 1 plus 8 is 7. Negative 1 minus 8 is negative 9, okay? I have a feeling that negative, though, is not going to be a solution. But let's see. Sometimes you could get a negative, and even though we're talking about a length, when you plug in the negative, it could still end up being a positive. All right, so remember, this is my length here. So my length, which is x plus 6, when x is 7, I'm going to get 13. So when my width is x minus 4 here, I'm going to get 7 minus 4, which is 3. Okay, so now I want to see if that other answer works. So length, remember that other answer that I had was negative 9. Negative 9 plus 6, when I plug it into this one here, nope, that doesn't work. I can't have a negative length. So we'll cross that off and cross this answer off because this answer doesn't work. Okay, so my dimensions then are 13 and 3 for the area. Okay, so that's it. Everybody, happy studying, and I will see you guys tomorrow.